Okay. How are you guys doing? Good. As you guys probably have seen, the homework is already online. It has been there since Thursday. And I got some messages, some questions in the forum, which is a sign that some of you at least have started working on the homework. It's a good thing. The due date for the homework is next Monday. The final is next Wednesday. Not this Wednesday, the next one. I decided it's kind of tough for you guys if I teach you material on Monday and demand you guys to know it by Wednesday. So on Monday, I'm gonna possibly solve the homework in class and maybe have a review section and some questions you guys might have. Okay, so there's no new material on Monday. Still is strongly advisable that you guys come, even if it's just to turn in the homework. Yes? I'll see if I have some practice questions about it, but the best way to work is going through the notes and doing the homework. And understanding, not simply copying homework, but understanding how to solve it. Okay, today class is about auctions. Today class is about auction. It's another application of game theory. We're going to apply some of the concepts we have found here so far of what is a Nash equilibrium and to see how this is applied to the auction framework. This is a really important example because it used to be the case that auction was something very rare in life. It used to be only when people died or for some weird reasons they would have auctions. But your generation, and mine as well, we see auctions every day. If you buy stuff in eBay, if you buy in other websites, that's an auction. If you sell stuff in Craigslist, sometimes if you have an open price, that's an auction. And more and more, all the time you want to sell something, but you're not exactly sure about which price to sell. Let's say you are in an M&A company and you'd like to, you are splitting a big company that and you're going to sell it for profit. Well, maybe you don't know how to do this, and maybe an auction is a good approximation for every time you're not sure which price to charge. The government in this country is about to organize an auction for the radio spectrum, and this auction is supposed to involve like $15 billion, or save the government about $15 billion, and it's going to involve way more money than that. So auction is an important part in economics. It's a growing thing in economic life. So that's why I think we should start today's class by having an auction. I have two goods here. And you are all band aid points. First one is a post-it. It's simple like this. You guys are going to bid in the post-it. Post-it? Are we okay with that? So I know that some people really use them and like to use them, and some people don't use them at all. But you're all going to start bidding on this, and you're going to bid in the following. It's going to be an increasing auction. I'm going to ask you all guys to raise your hand, no, nothing. And then I'm going to increase 10 cents by 10 cents. And if you don't want to pay the price, you just lower your hand. And the last person with their hands up wins the good, and then the class has the possibility of buying the post-it from me if you want. Are we clear on the rules of the auction? So, I'm the auctioneer now, and I'm selling this post-it. I'm going to ask you all guys to raise your hands, and the first price is 10 cents. I'm going to assume that you're willing to pay 10 cents. I said everyone raise the hands. Good, now we're talking. Raise your hands. 10 cents you're willing to pay for the post-it. Raise your hand. 20 cents, who's willing to pay 10 cents? 30 cents, if you don't want to pay 30 cents, you lower. 40 cents. Raise your hand. 50 cents. 60 cents. 70 cents. 80 cents. 90 cents. $1. $1.10. $1.20. $1.30. $1.40. $1.50. $1.60. $1.70. $1.80. We still have 3 people here. $1.90. $2. We still have 2 people here. $2.10. 220, are you backing? 230, 240, 250, 260, 70, 80, 90, $3, 310, 320, 330, 340, 350, 360, 370. Do you want to buy? 370. 370 sold for a gentleman here in the front. So that's your name again? Simon. Simon has the right to buy this one there. So Simon got it right. She just lowered her hands at 270. So Simon has the right to buy the post on behalf. Just so for your curious, it costs $390 in the shop. So that's a pretty good job auction. Fine. This was one way to conduct the auction.
Wait, does he have a right or is he committed?
Through auction, he should be committed, but I don't think the rules on the verse allow me to enforce taking money of you guys. Otherwise, I'll be making way more money than I am as a teacher right now. So I'm going to give him the option to buy from me. In the auction, he should be committed. I cannot refuse if he wants to buy from me. And now I'm going to auction another good, but I'm going to do it a different way. Instead of going up, I'm going to go down. I'm auctioning a bag of M&Ms. I'm going to start with $5, and I'm going to go down until the first person raises a hand. Oh. Yeah, it's a different scheme of auction now. Okay? $5, $4.90, $4.80, $4.60, $4.40, $4.20, $4, $4 in one, $3.80, put them in the back. 360, 340, 320, $3, 280, 260, 250. 250 sold for the lady there in the back. What's her name again? Alison. 250, and you can come here and purchase. It costs more than 250 in the shop. Yeah, I'm not sure about it. So what we just run here were two different auctions, different auction designs. And it's a very common part of life now. It's becoming way, way more important. And I'm going to give you here just a hint about, just a tip of auction theory. There are also other classes here in UCLA that they cover more. It's just going to be one class about the topic. Okay? And then we can talk a bit about auction. We have these two examples. I'm going to talk about the auction framework. And then we're going to see two kinds of auctions. The first price auction and the second price auctions. And then I'm going to talk about the important revenue theorem. It's a benchmark in this subject. Any questions? So in the beginning of the framework, you have n different buyers for just one good, okay? And one thing that is very different from the other games that we've played, in the other games, we knew exactly what what valuation we had for the good and what valuation the others have. We knew exactly what was the payoff in the matrix that the other would get. In this case, it's different. I don't know what is your valuation. I know the Simon values the post-it more than 350. 350? Yeah, more than 350, but I don't know exactly how much he values. All you know is how much you value the good. So we have asymmetric information. Okay, so you know that you value VI, which would be some amount of money for the M&Ms, but you don't know what is the other valuation. But we know something about the other valuation. We know there's like a possible distribution of valuations there, and he's like a random variable. There is a value from this possible distribution of valuations. One example would be something like this. Well, I think that I don't know how much you guys value the M&Ms, but I'm going to assume that you value the M&M is like a distribution, which is a normal or bell-shaped distribution, around $2, for example. Some people value like 0 because they don't eat chocolates at all. Some people might value $4 because they're craving for chocolate right now. Okay? And there's a distribution of possible values for the M&M. So I know that the valuations of the orders come from a uniform that's between 0 and 4. It could be anything from 0 to 4, and the possible values are uniformly distributed for the M&M. That's one example. We also assume that you have private valuations, which means that those valuations, V1 is the valuation the bidder number 1 has, V2 is the valuation the bidder number 2 has, and Vn, they are independent of each other, and they're identically distributed. This does not have to be the case. There is not a possibility to say there are common values. If, for example, we can accept that some people they really like chocolate differently. Maybe I really like M&Ms. Maybe you guys don't really like M&Ms. Maybe you're allergic to peanuts. So how much I value M&M does not influence how much you value M&M. But if instead of M&M, this was a wallet full of money or an oil well, then we might have common values because there's just one price attached to it. And that's a different kind of model. We're not going to study it here. If you want to learn this, there are other classes in auction theory. But there's another possibility that we all should have always the same valuation for the good. We just don't know where the valuation is. And the last point that I'd like to make, you're going to assume that you have a specific utility for. So your utility is going to be I'm sorry?
Why is
I'm sorry.
what is the
Oh, T is the amount that you have to pay. TI is the amount that you have to pay if you win. Yes, Sasha.
Is that a negative TI?
It's a negative TI.
Top and the bottom?
The bottom, yes. Different color, it might be helpful. This is a U. Yes. Sorry? We'll just put here the legend, and then I will try to elucidate this utility. Okay. So this is the utility you're going to get in the two possible cases. There is one case that you win the good in the auction. For example, you won the M&M, and in this case, you get to enjoy the M&M, but you lose the price that you paid for it. And there's another possibility that you don't get the M&M, but you might still have to pay something, or maybe you don't. Depends on the framework of the auction. In both cases here, in both auctions, that I run here in the beginning of the class, you would only have to pay something if you win the good, right? I just said title, now you won't have to pay, and I said to her, where's the girl who won the posting? The M&Ms? She left?
The bathroom.
She's like, she's not right to buy. Okay, forgot her. And she would have to pay. But you other guys did not have to pay anything for not winning. And that's one specific case where the price that you pay if you lose is zero. Some other auctions out there, this is not the case. Does anyone know a kind of auction? A kind of auction that you have to pay even if you don't win? Yes. Yeah.
Maybe like a fee to participate.
Fee to participate is one possibility. Do you know something?
There's like the penny bids.
The penny bids, you have to pay for bidding, right? There's also some auctions that are like all pay, which means you bid whatever you want to bid, and you have to pay the value. If you win, you get the good. If you don't, you pay the value no matter what. There are different kinds of auctions out there. In most of the common auctions, this is zero, but they're not all of them. You can maybe have to pay a fee, as Adia said, a penny auction as Tiffany. Yes, as Tiffany said. So, in most cases, zero, but not always. The important assumption here is that utility is the value of the good minus the amount that you pay. Yes.
So if you don't get the good, why is the utility minus T as opposed to, like, if you, it's, you know, if you're willing to bid $10, that's how much you would pay, so that's obviously subtracted from the utility that you get if you win. But if you don't win, you still have $10. So shouldn't the utility of that actually be T?
No, okay. We are looking for like the utility for entering the auction, right? This is like, if you enter this auction and if you win, your changing utility is going to be minus T. What you get, like let's say you valued them $5, but you only have, you won it and you only paid 2, it means the utility for getting this auction is 3. And if you lose, and you don't have to pay something, is 0. I don't add, in this kind of utility function here, I don't add this extra outside money. You see what I mean? It's like, the outside money that you have here doesn't matter. It's in the case that you don't win the auction and you have to pay 0, your utility is 0. I could simply add the money that you have on your pocket to this here, but then this here would be the difference in utility minus the money that you have in your pocket, and this would be just the money you have in your pocket. So let's just ignore money that you have in your pocket here, which would be just adding a constant. Okay? If you don't win and you don't pay, your utility is 0. It's just a scale, not scaling. And it doesn't change anything. But that's a particular utility function. There are other utility functions. If you take into account money here, would do different things. And we don't really know how to solve problems with other utility functions. Any other questions on this? Okay. So let's think about this in a game framework. What is possible strategy here for the guy? Well, I don't know. When I see the good that Tiago is auctioning in front of the class, I don't know what he's going to pull out of his bag. But when he does it, I say, oh, look, an MM. I really like MM. I have utilities, 3 for the bag of MM. I have no idea how much the other people value. And now I have to discover how much I'm going to bid. How much I'm going to say that I would like to pay on that M&M. Do you have a question?
Well, the utility, because the T is the amount you pay, what units are the utility? So how can you even it out? My utility is 3, but I value it at $3.
Yeah, we are like
the same thing, the 3 and 3.
Well, in this specific utility function here, right, money counts as one of utility. Okay, that's an assumption. It simplifies the problem a lot, and we don't really know what to do without this assumption. But money usually is a good thing to be actively scaled on. So it's either utility or money since they're equivalent under this utility function. What was it? So a solution, a strategy for this problem would be a bidding function that I take my value as an argument and give a bid for the good. So I would like to find the strategy that yield an equilibrium for that. So the strategy will be a function. Okay? So far, maybe it's not very clear that what is these bids that you should make. Because in the way that I designed the two auction here, there were no bids. But let's say I came here, every day we come here, in the beginning of the class, we have an auction. And one of these days, I come here and say, look, my voice is really not working very well. Okay? I cannot keep yelling here and shouting different prices. So I'm going to ask you guys to do, instead of doing the descending bidding auction that we did for the M&M, I'm just going to ask you guys to write down the amount of money that you would like to pay for it. Okay? Instead of going $5, $4.80, $4.60, going down, I'm just going to ask you guys to write down on a paper. Just write down on a paper how much you'd like to bid. And I'm going to collect all of them. And the one who has the highest wins the good and pays that money. Understand how it would be? Instead of raising your hand and shouting, or raising your hand when I say $250, you just write down $250, this is how much I want to pay. I'm going to look at the highest one. And your bid would be $250. So a strategy would be to figure out how much you value the good. I'm sorry, your name again is? Yeah. Alison. Alison would probably think, well, I value M&M $3. But I don't want to pay $3 because if I pay $3, I'm not going to get any utility from this. So I'm going to pay offer a little bit less than $3, so I still can profit a little bit from it. So she's going to figure out how much she values M&M, and now from how much she values the M&M, she's going to make a bid, and she's going to write in a paper, and I'm going to pick the highest one possible. And she's going to pay that value. So a strategy would be a bidding function, something that comes from her valuation, and from her valuation, she's going to find a possible bid to bid. And we would like to solve for different auction designs what is the optimal bidding function. And now possible applications, if you want to buy a company, if you're in a huge M&A process, and you guys got there, you're going to go to an auction, and you have a bunch of firms that would like to buy this company, and you have your own valuation, and you have to figure out how much you'd like to bid out of that. It's a very applicable solution, so I'd like to compute this bidding function. Now, so what I just told you now was one specific of auction designs. There are many types of auction designs. So, an auction design is like a rule that specifies payments an allocation of the good for each combination of bids. The most simple one, the most common that you probably have seen in the movies, is the one that I just talked about. We call it the first price auction. It's simply like this. Everyone submits a bid, and the person with the highest bid wins the good and pays exactly her bid. And that's the only payment that is made. Anyone knows another example of auction design? Someone mentioned here, Tiffany. You mentioned another possible auction design, right?
Penny bids.
And how does penny bids work?
You pay for a certain amount of bids you can make, and,
Okay.
and then for each bid you make is a penny.
You have to pay a penny for each bid.
And then if you win the highest bid, then you pay that amount.
So you pay the highest, the person who gives the highest bid pays the full amount, gets the good, but you pay for every bid, right? Anyone knows another one? Well, Hadia mentioned one, like auctions with an entry fee. Right? Sometimes you have to pay to show up in the room. And quite often governmental auctions, this happens. At least you have to provide some insurance that you can, you have to be pre-approved to bid in some of the auctions. So, anyone knows another one? Sasha.
Silent auctions.
Sorry?
Silent auctions.
Selling auctions?
Silent.
How is silent auction?
So there's an item or whatever, and you go up to the item and you write down the price that you would pay and the person that pays the most. Say that there would be most has to take them out, but sometimes they pay them out anyway. It's like a charity.
And is it different than first price auction?
What is that?
First price auction is like,
No, yeah, because sometimes in charities you have to pay the amount that you say anyway. So let's say
oh, so how much?
yeah, you still donate the amount that you would write.
So you donate how much you want, and whatever you donate, you pay, but the person the highest gets the good.
Yeah.
Okay, we have another name for this. It's a silent auction, but it's also called all-pay auction. Everyone pays the value, but it's exactly that. All-pay auction, which is also known as, I just learned this, silent auction. Good. Do we have any more examples? Yes,
For
okay.
the silent auction, though, you don't have to, like,
Yeah,
all
so
of
it's
them.
only some of them.
Only some of them you have
only
to
some of
pay
them are
all
all
the time.
fixed.
Sometimes you, like, they give you a time limit.
Okay.
Say it as a 7 o'clock, so you have up to that time, and people can keep going, writing down how much they want to bid.
Right.
And people can pass you up, and then whoever bids the most at the end gets it, and nobody else has to pay.
Okay, so sometimes silent auctions are like first price auctions, sometimes they're like all-pay auctions. Right? If I get this right.
The first price auction, though, I thought you were saying is just the person who bids first.
No, the person who bids highest. The highest, everyone bids, the highest bid wins the good, but only the person who bid it highest. Hadir.
Different than the one where they put what they want to pay on paper, or
It's the same one. First price auctions. You put in the paper, and only the person with the highest bid, we get everyone bids, and only the person with the highest bid pays that value and gets the good.
what about the one where there's options that going
Go-
once, going twice,
Yeah,
just
that's another type. That is go up or down.
up, like the normal one. The
Okay.
The one that's known.
I don't know. There are many kinds of auctions out there. increase open auction, how does it go? Increasing open auction? Yeah, increasing open auction. That's the one that is like 10, 20, 30. Increasing open auctions. This is also known as English auction. Now there's also the opposite, right? The one that I did for, this is what I did for the Post-its, the Simon one. There's also the one that I did for M&Ms, the going down. And that's how they used to sell tulips in Netherlands. You know, I just started with a really high value, and then I go down. That's the decreasing open auction. And I have one more that may sound kind of crazy for you guys. I'm going to call it the second price auction. And I'm going to put here where the second price auction and the first price auction are. So the first price auction, as it was described, is a quite common type of silent auction. Is that everyone bids, and the highest bid wins the good, and he pays his bid. And the losers pay nothing. Now I'm going to tell you about another possible auction, which is the second price auction. Which is very similar. Everyone bids. The highest bid wins, the highest bidder. The person with the highest bid wins the good, and he pays the second highest value. And the losers pay nothing. So let's think about this first price auction here. When I came here and I start auctioneering the M&M, I was going down and saying $5, $4.80, until we get to the point that someone said $2.50. I'll buy it. And that's exactly the same thing that she would have done in a first price auction. If she had written down how much she would like to pay for the M&M, it would be exactly the same thing as if you submitted a closed bid, and she would pay only the value of her bid. So this kind of auction here, the first price auction, is isomorphic. It's exactly the same structure as the decreasing open auction, as going down. Yes, Philippe. Okay. Let's go back to the M&M example. Let's say that instead, actually I should have done this. I kind of forgot this detail. That instead of just asking you guys to bid, to raise your hand when I reach the price that you'd like to pay, I could say, instead of just raising your hand as I reach the point, just write down in the paper how much you'd be willing to pay for the good. Okay? Try to remember when I show you, trying to evoke the same emotions. When I show you this, how much you'll be willing to pay for this. And now write down on a piece of paper how much you'll be willing to pay. And instead of going down value by value, I'll just ask you guys to give me the piece of paper where you wrote down how much you'll be willing to pay. And I'm going to charge you, I'm going to give this to the person of the highest bid, and the person of the highest bid is going to pay exactly the amount of money that they wrote in the paper.
Isn't this the same thing for the increasing one?
No, let's talk about the increasing one.
Yes,
Yes,
for first function, the participants are aware of like other bid.
No, they're not. Because, well, it's a little bit, not in the first price auction. No, in the first price auction, they are unaware of what other people, of how much other people bid. They should know how many people are bidding in the room. This is important.
So, like in that scenario, isn't the incentive to go higher and higher, whereas in the decreasing open, you're just like capping the price, kind of limiting your revenue?
Say it again. I'm not sure I understand.
In the first price section, like I don't know what my person next to me is bidding, so I would try to like outbid him, you know. So that would likely result in higher bids.
In the first one?
Yeah.
But in the first one, you have to pay your value.
Right.
In the second one, you pay the second highest one.
No, I'm just comparing the decreasing in the first price section.
The decreasing in the first price
If you don't
auction.
know what others are bidding, aren't you more likely to bid higher?
If you don't know what others are bidding, you're not more likely to bid higher. I don't know, in both cases, you don't know how much others are willing to pay.
Well, in the decreasing, you know that it's not going to be any more than like 5.
True, but I could have kept them at 5. And what have you learned about how much is he willing to pay by the time when the time passes? Not very much.
So you're saying the uncertainty doesn't result in high bids?
Well, what I'm saying is, under the assumption, we have an assumption here. I think you have a point. But we have the assumption that we have private valuation of goods. That how much you value this, how much he values doesn't matter at all for you. If you had the assumption that instead of being a bag of M&Ms, this were a bag of money, and he had an assessment of how much money was in there and a different one, then you would like to know what he thinks about it, and what he thinks about it would matter for you. And there's also a phenomenon called the winner's curse. The person who pays the money, who wins the auction, quite often loses money because the person overvaluates the good. But not exactly in this case here, because how much you value the M&M is completely independent of how much you values.
So you're assuming that
In this scenario, under private valuations, first price auction is equivalent to decreasing open auction. You have some reason when they come with evaluations. Going to solve it. But now going back to this point, let's think about the second price auction now. Okay? When I came here to sell the post, I said, everyone raise your hand. And then you lower when you don't want it anymore. Okay? This is how we did it. If instead of asking you simply to raise your hand, I came here and said, my voice is not very well today, I'm going to ask you guys to simply write down in a piece of paper how much you'll be willing to pay. Okay? Which is your private valuation, the maximum you pay for this. And I'm going to tell you guys, look, I'm going to get back all your valuations, and I'm going to give this good to the person with the highest valuation, but this person is going to pay the second highest bid. Actually, I'm going to give this to the person with the highest bid, and I'm going to and this person is going to get the good, and you're going to pay the second highest bid. If you think about it, this is exactly what happened when Simon won the good, right? You paid $350, but $350 was the price that she was willing to pay, the maximum price that she would pay. I don't know how much he values the good. Maybe he values $10. I don't know. I don't know what's the maximum that he's willing to pay. He got the good, and he paid the value that the second highest person was willing. It's kind of crazy, but this auction here is isomorphic. It's equivalent to this auction, and this auction here is very common. And solving this auction here is kind of easy. We're going to see. They're equivalent under the assumption that they're private valuation. Under common valuations, they're not so good. So this guy here, that's why those are some typical examples in economics. Not because we see second price auction every day. Actually, some of the companies are starting to have second price auctions, but because they're equivalent to this other kind of auction, which is very common. Finkel.
Do you mind explaining the penny bid?
I'm going to get to the penny bidding there. But the idea is you have to pay for it's like a sequential game where you have to pay for every single bid that you do. If you bid, you have to pay a cent. Yes?
General question, what is the objective to decreasing open tab? What purpose does that design serve? When you're lowering, going down on the side?
What do you think should be the purpose of an auction? If I have a good and I want to sell an auction,
If I'm selling something, I want to go to the higher price.
you're going to get as much money as you can. And let's think about these two auctions here. Which one do you think yields a higher revenue? That's the question of the end of the class. What the auctioneer would like to do is to design an auction that gets him the most money possible, right? Which one do you guys think is the first price auction or the second price auction? Actually, just for a second, I'm going to make a vote. Everyone has to vote. Everyone has to vote, and I'll remember if you don't. Yeah. So who thinks, do you understand? I want to see, one of them is going to give one expected revenue, and the other is going to give another expected revenue. Okay, so the first price auction, you think that the person wins and pays the highest value. In the second price auction, the person wins and pays the second highest value. So who here thinks the first price auction is going to yield the highest revenue? Raise your hand now, higher. Okay, now who thinks the second price auction is going to yield the highest revenue? Why do you think the second one?
Well, because a lot of people have an ego, so if it's like down to two people, I feel like I would go higher even though it's above.
But what if it's completely, but you also have an ego for the first price auction. But what if it's completely blind? You just submit a paper. No, I'm assuming that, that what you put in the paper is going to be your bid. It doesn't have to be a valuation. Well, what's going to happen here is, well, if you're going to pay the highest bid, in the end, the auctioneer is going to get the highest possible bid. In the second price auction, you're going to get the second highest bid. So that's a push towards this one here yielding more money. But also, if people know this rule, they're going to bid a little bit more in the second price auction than they're going to bid in the first price auction. Because they don't have to pay so much, so they can bid a little bit more. How are those things going to average out? Which one is going to yield the highest revenue? That's an important design. That's a $1 billion question. I'm not exaggerating of billion. The option for spectrum of radians are in tens of $1 billion. So that's a lot of money into the question. How to design the best option. And we're going to talk about this the rest of the class today. Hadir, had a question. You still have it? Good. Lucy.